All right, welcome to another episode of Young Learning. We're going to talk about Unit 2. Unit 2, Lesson 1. We are talking about the planning a pizza party. We're going to have a couple of things that we're going to do today, and we're going to talk about expressions. So we're going into algebra today, which is a great thing about it. Now we're not into stats, we're actually going into algebra and all that stuff, which is a great representation. Hopefully you'll be able to understand it. So let's take a look at the first problem. Now this is our warm-up. So our warm-up is going to be representing how these represent our dishes. Okay, main dish and some side dishes. So this is our warm-up right here. We're going to talk about this and everything like that. So let's talk about M. M represents the cost of a main dish. So just remember, the cost of a main dish is M, where M is a main dish. So this cost, so that's going to be a dollar amount. N represents the number of side dishes. So N represents how many side dishes you have. This is not a dollar amount. This is the number of sides. So you have French fries, broccoli, mashed potatoes, mac and cheese, all that stuff. How many of those are you going to order? And so forth. So that's what N represents. S represents the cost of a side dish. So basically how many side dishes you want times how much the side dishes cost. So these two are going to be related together in some way. Either we're going to multiply. We're not going to add, because think about it. If you have two side dishes at $2 each, how much do you get? 4. That's a terrible example. How about two side dishes at $3 each? How much is that going to cost? 6. We're not adding them, so it's not going to be 2 plus 2. It's going to be 2 times 3, because it's 3 plus 3. So how many side dishes represent how much each cost of a side dish is basically how many numbers times how many side dishes there are. Okay, and then T represents the total cost, basically how much everything costs total. How much the main dish costs times how many side dishes you order, and then times how many dishes, how much the dish costs. So let's take a look at it. Okay. Discuss with a partner, what does each equation mean in this situation? So M equals 750. Well, let's take a look at M. M represents the cost of the main dish. So M is basically $7.50. So this M is the main dish, and it's going to cost us $7.50. Okay, so that's what we're writing. We're saying that M represents the main dish at $7.50. Okay. The next one is M equals S plus 4, which means that M is $4.50 more than the side dish. So that's basically what it is. So the main dish is $4.50 more than the side dish. Okay, it just means that. Well, we talked about this. N times S is equal to 6. N represents the number of sides. S represents how much it costs. So basically it's telling me the number of sides times the cost of each side. Okay, and that equals $6. Okay, number of sides times the cost of each side is equal to $6. Last but not least, M times N plus S is equal to T, which means that is the total cost of the meal. So that's everything together. M is how much? In this case, it's $7.50. N plus S is $6. So $7.50 plus $6 will give us how much it costs. And in this case, it's what? $13.50. Okay, so let's look at writing a new equation. Write a new equation that could be true for this situation. We can do a bunch of stuff. Okay, the first one's easy. We don't know what n is, so we can always make an equation where n equals 2. So if n equals 2 means that we are asking for 2 dishes. That means the cost of s will be what? S has to equal, well, 2 times what will give me 6. S means it's going to be, we are going to take $3. So 2 dishes at $3 a piece equals $6 total. Another one we can do is basically we can say that the cost of the meal minus the cost of the dish is $4.50. So we can say that m minus s is equal to $4.50. Okay, so the difference between the main dish and the side dish is $4.50. Okay, and last but not least is we can probably take the total cost of the meal plus $6 is equal to $13.50, which we talked about. So those are our new equations that we can write down. All right. So there we go. There we have it. New equations. How much will each cost? Imagine your class is having a pizza party. Work with your group to plan what to order and to estimate the cost. So we're going to go through this slowly. We're going to make up some numbers here. So let's say that we have work with your group, record the group's plan to cost that. Let's say we have a class size let's say we have a class size of about 28. Okay, we have a class size of 28 in the class, and let's say each person is going to eat 2 slices of pizza. Okay, so then we can record our group's thing. So let's say we have 28 people at 2 slices of pizza. We know for a fact that 28 times 2, that gives us 56 slices. Okay, on your paper you're gonna have to write this down. Okay, so you're gonna have to write it in complete sentences. Make sure you type all of this. So 28 times 2 is 58 slices of slices needed. Okay, what else can we do? Let's say 1 pizza. Okay, let's say our next thing is 1 pizza, or 1 large pizza. And these are examples. You could change yours if you want to. 1 pizza is 8 slices, right? 1 pizza is 8 slices. So how many pizzas do we need? Well, in this case, how many slices? How many pizzas do we need? If we need 56 total and there are 8 slices in 1 pizza, we know that we need 7 pizzas, right? Because 7 times 8 is 56 slices. So we need 7 pizzas. What else do we need? Well, we need the cost of pizza. So there's here's 1, here's 2, okay. Here's 3, okay. So the next one over here is we are gonna need to know what the cost of the pizzas are. So the cost of the pizzas is, let's say, a large cheese. Large cheese is $11. And then pepperoni is $13 per pizza. So now we can go through our entire thing and figure it out. So we need 7 slices of pizza. What's our next thing we're going to need? Let's say we need 7 slices. So we're going to say we're going to need 4 cheese, and 3 pepperoni. Okay, so these are the things that we need. Okay, we're gonna plan this out. Okay, we need 28 slices. We have a class size of 28. Each person requires 2 slices, so 2 times 8, 28 times 2 is 58 slices needed. So that means that one pizza, since one pizza is 8 slices, we need 7 pizzas. So, and then now we have to go to the cost. Large cheese is 11, pepperoni is 13. So that means, and then we need 4 cheeses and 3 pepperoni. So that means at the end, we're going to state that what? We're going to state 4 times 11 plus 3 times 13. And that gives us a total of $83. Okay, $83 is our total of how much it's going to cost us to have all these pizzas. Okay, we'll come back to that. This is what you should be writing down. Write down one or more expressions that shows how the group estimates the cost. We're going to go through that. So the first estimation is going to be what? How do we end up having 7 slices of pizza? Let's change this to a different color. I like the different color. How we're going to end up having 7 slices of pizza, 7 pizzas, not 7 slices. How are we going to end up how do we end up getting 7 pizzas? Well, in this case, our expression would be what? Well, we have 28 times 2. That gives us 56 slices. And 56 slices divided by 8. And that should give us 7 slices. Okay? Well, it's an expression. So just know that an expression does not have an equal sign. So an expression is basically the same as an equation without an equal sign. Okay? Okay, so you're only having one side. So we know that we can find the number of pizzas. So in this case, this is the number of pizzas, which is 28 times 2 divided by 8. We can also find the cost of the pizzas, right? The cost of the pizzas. So the cost of the pizzas is 4 times $11 plus 3 times $13. That will give us $83. Well, there's something that we don't know, obviously. There's something that we have to figure out. A lot of times that we have to also talk about taxes, the big thing they call taxes. We never talk about taxes, but we have to. So taxes is basically how we're going to do this. So we know we have 83 pizzas, or $83. We talked about that up here, $83. And we have to talk about taxes. 83 plus 83 times 0.08. We're going to say taxes are 8%. Okay, so taxes over here, that is considered to be 8%. Okay, it's a percentile. And this is how we get our taxes. You know how 99 cents becomes $1.07? It's because of taxes, and that's how we do it. You take your total amount and multiply by what the tax value is. In Santa Monica, it's about 8%. In the Valley, it's about 10.2. So, sometimes you want to go somewhere else to buy your stuff and everything like that. In Vegas, it's like 6%, which means everyone wants to buy stuff in Vegas because the taxes are cheaper. Next, in your expressions are the quantities that might change on the day of the party. Which one? So we're talking about things that might change. Slices of pizza slices, they're not going to change. We know that slices of pizzas are not going to change. We can, the need of pizzas could change, but that's not what we're talking about. We need something concrete that changes all the time. The big one is that we are going to make sure that we have 28. 28 can change because why? What could happen? 28 students. Well, it could mean we could have students absent. Okay. Students absent could affect this. So we know that absence of students. What else could possibly change depending on unforeseen factors? Well, the cost of pizzas. We all know that pizzas, when we order pizzas, that we are always looking for a cheaper price because we're not paying $20 for a pizza. So that is also another reason that can change, that we have pizza specials. Okay. Specials on pizzas. And that could help us change some of the things. I mean, if you order more than three pizzas, this price goes down. So that means that you're ordering four, which means that this price could go down. So those are some of the reasons why we could have it. Pizza shop could have a special, or students are absent and we need less pizzas now. Rewrite your expression, replacing the quantities that might change with letters. Be sure to specify what letters represent what. So we're saying that the number of students. So instead of 28, it tells us replace the quantity that might change with a letter. So we know for a fact that 28 is going to be a letter now. So instead of 28 times 2 divided by 8, we know we can change 28 to n. So n equals the number of students, which means that our expression becomes n times 2 divided by 8. That is one expression. Okay. The other expressions could be that the price of our pizzas, instead of $11.13, because it might change, just like in part A, it says that pizza prices could change because of specials. We're going to rewrite these. So we're going to say cheese is going to be C. Let's go to cheese pizzas. And this is the dollar amount of cheese pizzas. And then P is the dollar amount of pepperoni pizzas. Okay? Which means that we can change our expression to look like this. 4 times C plus 3 times P. Those are our expressions. As you can see, this looks like a normal algebra problem now. And then we'll make it equal to something eventually. Okay. Not bad so far. Not bad. Now, this one. This one you're going to have to do on your own, so be prepared. Do this on your own. Okay? Look up a website. You can always find it. It says that find a pizza near you and ask about the diameter and cost of at least 2 sizes of pizza. So you would go to Domino, look up Domino's pizzas, Pizza Hut, Amici's, Papa John's, okay, and find out how much it costs for a specific pizza. 2 specific, maybe large and medium, medium and small, and compare the cost per inch, okay? So just look it up, figure it out, fill it in yourself, okay, and tell me what you think it's going to be. So now, we're going to talk about keywords. Next one, what are constraints? So constraints. Constraints is something that limits what is possible for or reasonable in a situation. Basically, we are looking for a way to make something have restrictions. Basically, you can't go past this, but you can't go under this, and so forth like that. So we're going to look at an example. For example, one constraint in a pizza party might be the number of slices of pizza each person could have. You're going to run out of money if you buy too many pizzas. So we're going to ask for people to not eat more than 4 slices. So that means we're looking at S less than 4, which says that the person gets only 4 slices or less. You can have 1, you can have 2, you can have 3, you can have 4, but you can't have 5 because we're running out of pizza. So that's all you can have. So let's look at our first question. Look at the expression you wrote when planning the pizza party earlier. Choose an expression that uses one or more letters. Which one would have one or more letters? Well, let's take a look at our expressions, our equations here. Let's take a look. Our first equation was 28 times 2 divided by 8. The expression became n times 2 divided by 8. That's only one letter, n. The other one has 2 letters, 4 times c plus 3 times p. So that is our equation that we're going to look at. Okay. We're going to look at 4. Oops. Let's change this to black. We're going to say 4 times c plus 3 times p. Okay. Where c, where c is the cost of cheese pizza, and p is the cost of pepperoni pizza. Okay. So that's our first one. For each letter, determine what values would be reasonable. So we're looking at restraints. So we're going to look at the cost of cheese and pepperoni pizzas. For instance, could the value be a non-whole number? So it could be decimals. A number greater than 50, so something bigger than 50. A negative number, exactly 2. So we're going to look at constraints. So we know that pizza is a cost. And because costs can only be positive numbers. Since costs can only be positive numbers, that's one of our restraints. That could be one of our restraints. What else could it be? Well, we don't want it to be cheaper than a medium pizza. If we're looking for a large pizza, we want to make sure that it's not cheaper than a medium pizza. So we can make sure that it has to be, so the pizza has to be more than $7.50. We don't want it to be smaller than that because that's just, you're going to run out of money at that point. And that's why we want to make sure that it's going to be profitable for the pizza company. So we know that the pizza has to be, a large pizza has to be more than 75, but you want to make sure that it's not too expensive where people weren't going to pay for it. But has to be less than $20. Okay. So that way we have our constraints. Our constraints is it has to be a positive number, and then it has to be more than $7.50 but less than $20. So let's go ahead and write an equation or inequality that represents some constraints on our pizzas. If a quantity must be exact, use equal. If it must be greater than or less than, we use less than or greater than sign. We've seen these before in 8th grade. So what would be one thing that we're going to do? Well, we're going to take our little cheese pizza. So let's say A. Our cheese pizza has to be somewhere between what? We know that C is positive. So how do we say C is positive in math? C has to be greater than 0, not equal to, because you don't want it to be free, but you want it to be greater than 0. So this makes it a positive. And C has to be greater than $7.50. Ooh. Maybe I'm gonna have to write this greater than 750. Ooh, that looks a little better. And C has to be less than 20. And we do that for P also. B has to be greater than 0. And P is greater than, well, in this case, the cheese pizza is $7.50. Usually pepperoni pizzas are more expensive because you have to add more food. So let's say C is greater than $10 and P is less than 20 still. And there you have it. These are our expressions. These are our constraints. So constraints mean that you cannot be over these things. So your cheese pizzas cannot be $21. That's too much. But your cheese pizza can't be smaller than $7.50 because of the fact that your medium pizza is probably $7.50. So you want it to be more than that. Or that means, why would you order a medium pizza if a large pizza is the same price? Same thing with pepperoni. Pepperoni's $10, but it can't go over 20. Okay? So let's take a look at our summary right here. Okay? Our summary is going to be based off of expressions, equations, and inequalities of mathematical models. They are mathematical representations used to describe quantities and their relationships. Okay? In real life, often what we want to describe are constraints. Constraints is something that limits them. What is possible is a reasonable situation. For example, when planning a birthday party, we might have to deal with these quantities: number of guests, cost of food and drinks, cost of a birthday cake, cost of entertainment, total cost. Constraints, don't have enough room, so 20 people max, $5.50 per person, $40 for the cake, $15 for music, and $27 for games. No more than $180 total, because you don't want people scared, So that means our constraints here is going to be n has to be greater than 20 because you want it to less than or equal to 20 because you want it maximum of 20. So you want n is less than people. Cost of food is $5.50 times the number of people. Okay, $5.50 per person for food and drink. So that's why we have number of people, $5.50 times the number of people. Cost of the birthday cake is $40. Cost of the entertainment is $15 plus $27, because that's what we talked about. $15 for music, $27. So you add them together. And total cost cannot be more than $180. So it's less than $180 right here. Okay, so our equation is our total cost is $5.50 times the number of people, plus $40 for the cake, plus $15 for music, and $27 for games. Okay, there's our constraint. Or you add them up. So $5.50 times n plus $82 extra, because this is basically extra. Okay, and that's basically how we write an equation. So we're going to dive into more of this in lesson 2, but this is what lesson 1 is about. Trying to deduce what an equation is going to be, because in our state testing, we're going to have to learn how to make these expressions right here. Okay, and then you're going to have to explain them. So that's what we're trying to do. We're trying to explain how these expressions work logically, so that way you can figure it out when I give you an expression. What does the P mean? What does the C mean? All that stuff. All right, well, that's it for Unit 2, Lesson 1. I'll see you next time for another episode of Young Learning. All right, have a good day, guys.